And we're live. Welcome, everyone. I'm Alison from the Collision team. You're very welcome to this Cloudsmith masterclass today, hosted by Dan McKinney. Today, we'll be discussing securing software pipelines with continuous packaging. If you have any questions, please pop them in the Q&A tab throughout this session for our host, Dan, to answer at the end. The chat box is just for general chat, but please ask any questions in the Q&A tab. Cool. So Dan, I'll leave it to you to kick things off.
Thanks very much, Alison, for the introduction. I hope everyone is enjoying Collision so far, and thank you all for joining me for this masterclass talk, Securing Software Pipelines with Continuous Packaging. Today, I want to talk to you about continuous packaging, what it is, and why it is an essential but often overlooked aspect of securing your software supply pipelines. We'll take a look at the typical structure of a software delivery pipeline and talk about why we at Cloudsmith think that continuous packaging is the missing link that adds control, visibility, and performance. So first off, what is Cloudsmith? Well, Cloudsmith is a fully managed package management as a service. And we empower you and your teams to set up a private and secure delivery pipeline in minutes. Cloudsmith provides a single source of truth for all software that you build and dependencies that you consume. We enable you to isolate and protect your teams and customers from things like supply chain attacks and achieve secure distribution. We were founded in 2016, and as you've probably guessed, we're headquartered in Belfast in Northern Ireland. We have over 225 global points of presence, and we support over 23 package formats. And we also provide engineer-driven customer support 24/7. And now, who am I? Well, as Alison said, my name is Dan McKinney, and I'm the DevRel lead at Cloudsmith. I've worked in various roles in software development for over a decade now. I was a technical writer in fintech and a systems engineer in semiconductor manufacturing and in consulting. And now I lead developer relations at Cloudsmith. Now, over the years, these roles have made me passionate about a few things. I'm very passionate about developer relations and customer success. I bridge the gap between our users, the community, and our internal engineering teams. And I help our customers to get value from the product and be successful with our platform. I love good documentation, and that's whether I'm creating it or consuming it. Documentation, it often gets left to the end, but it shouldn't. Arguably, it's a more important part of a product than a lot of features are, as it's often the entry point into a product for a lot of users. Documentation really is king. And I'm also very passionate about a couple of things that are not software related, namely DJing and music. Now, before last year, I was a pretty successful DJ. I don't take myself too seriously, but I do love to share my passions. And this was the perfect outlet to share my passion for music. And finally, I'm extremely passionate about Lego. It's probably my biggest vice. I spend far too much of my disposable income on Lego. But I do think it's very important to keep your inner child well looked after. And plus, the bricks make really good traps for unsuspecting feet. It does help to encourage my children to tidy up after themselves. Now, you can find me on Twitter at DevRelDan. It's a new profile. I have another one that I use for music. So I would appreciate some followers. I do also tweet a bit about music and Lego, of course. So today, I want to introduce you to the concept of continuous packaging and why it's the glue between continuous integration and continuous deployment. Continuous packaging offers the observability and control to ensure that software is always verified, packaged, and ready to deliver. And packages and the narrative thread of how they were built, sourced, and integrated are vital to efficient and secure supply chains. So let's just start by thinking what a modern DevOps secure software pipeline looks like. Well, typically, it's got three components. So you have source code and control, and continuous integration, and continuous deployment or continuous delivery. Now, what do each of these look like? Well, source control is simple. It's something like GitHub where developers can collaborate on code and version changes. It's very well known, very well understood, and in widespread use. And then there is continuous integration. And this space is occupied by many tools. The most important thing that continuous integration does is bringing all source and dependencies together, building them, checking everything works as expected, and confirming this by running tests. Now, the output is typically a package or a container. It's a transferable asset with a bill of materials that's versioned and ready to deploy. Now, that asset sits alongside many other assets, and they are the building blocks for the next stage, which is continuous deployment or continuous delivery. Now, this is where the final packaged assets are usually tested again and then deployed to production environments or made available for delivery to customers and end users. Again, many tools and integrated platforms occupy this space. Now, DevOps is the methodology to automate these processes as much as possible, to provide continuous feedback end to end. Continuous integration and continuous deployment, they aim to trivialize the end goal, which is deploying software so easily that if you go to production and a bug or a vulnerability is discovered, you can easily roll back or undo your changes. Now, that statement masks a lot of complexity in these processes. It's deceptively simple to say that. And, a common view that most people hold is that it looks a little like this. Well, isn't that a very happy looking graph? And that's totally coincidental. Unfortunately, it's not quite representative of the reality of the situation. Now, everybody spends time thinking about the left and the right-hand side and thinking that that's where the complexity is, that building and integrating all the source is complex, and that deploying the build results to production environments or distributing to end users is complex. But the piece right in the middle, where you have to manage the packages that are the output of CI and the input for CD, well, it gets talked about very little. There are lots of great CI and CD tools. There's a huge selection on both sides. And even security tools now have a focus on the source and the CI side, with the push towards shift-left security. But the number of tools that occupy that middle space with a focus on package management is very low. In fact, it's just us at Cloudsmith and a few others. Now consider for a moment that coming out of the CI process, you have many assets, and going into the CD process, you also have many assets. So end-to-end software pipelines are really a many-to-many relationship. And as any mathematician will tell you, many-to-many relationships are complex. So in reality, it's more like this. Now, cloud package management makes these relationships many to one and then one to many. It's using a single best-in-class tool to control all dependencies and packages coming and going, creating a unit of value that you can then use and deploy. It levels the playing field between CI and CD. And at Cloudsmith, we call this continuous packaging. In order to build secure software development pipelines using a DevOps methodology, you need the ability to universally store and deliver packages securely and efficiently across all package formats and languages. And we believe that it fills a gap in a modern secure software pipeline. Now, ignoring source control for a moment, because while of course it is super important, it's fairly ubiquitous and almost everyone is doing it right already. We see a DevOps secure software pipeline as this: CI, CP, CD. We see continuous packaging as a glue layer between CI and CD. It sits in between and overlaps CI and CD. Continuous packaging is a differentiator of CI output and CD input. And another way to look at it is that continuous packaging should almost be a pinch point, somewhere that everything coming out of CI and into CD has to pass through, as that is precisely the point where you need the control. Again, it simplifies that many-to-many relationship that packages coming out of build and into deployment have. Now, we've seen patterns within customers of Cloudsmith where it is paying dividends to have a single source of truth for assets in their software supply chains. They have multiple teams with multiple deployments, and it's important that you have a single point where you can manage all packages, again, universally across all package formats in one place. And security teams in particular will thank you for that. So why continuous packaging? Well, I wish it was that easy. Continuous packaging gives your team security, control, visibility, and management over incoming and built assets. You have packages as the output of builds, packages pulled from public repositories, packages scanned and checksums and signatures verified, and then accepted or rejected, and packages promoted, through testing environments to production deployments or directly to customers. So really, it's packages and containers all the way through. And to break that down a bit further, continuous packaging provides you with three key benefits. First, provenance, which provides you with a chain of trust. And then second, isolation, which gives you the control and the visibility. And third, acceleration, which gives you the performance and faster delivery required for a single source of truth. So, well, first, what is provenance? Well, to put it really simply, provenance is trust. You need to know and be able to verify when packages and containers entered your supply chain and where they get deployed. So it's a single source of truth that gives you a single pane of glass for your software supply chain, from trusted sources right through to delivery, using things like package signature verifications and checksums to ensure that packages are from and are what they say they are. And it's vulnerability scanning, to continuously assess threats in your software and dependencies and protect your customers by shipping clean software only. And combined in a single source of truth, that gives you immediate knowledge. And that's particularly useful when automating builds and deployments as per the Devops methodology. And maybe another way to put that is that continuous packaging is a methodology for provenance and isolation for all packages and containers that you're using in your infrastructure. So what then is isolation, and why is that important? Well, it's generally accepted that a lot of the software you run is built by someone else. It's open source or it's built on open source. And this is the most likely channel of attack, with an infinite number of attack vectors into your code base. And when you connect directly to public package repositories or container registries, you've opened a door to let them in. But imagine having a layer in between where you can proactively prevent known vulnerable software from entering your deployments. You can cache assets and your security team can vet them. Or you can simply even pull a software bill of materials. Well, With continuous packaging, you can. Now, it's common practice in software development and in software build pipelines to configure a public upstream or repository that you need. Now, that public repository is ran and managed by a community that usually doesn't have full control over the packages that are pushed there. And those packages can be downloaded millions of times a day. So continuous packaging defines isolation as the ability to cache packages away from public upstreams so that you control package availability. If a package is removed, you still have a local copy. Or if a vulnerability appears in a new version of a package, you have previous versions you may be able to roll back to. Or even if a license changes, you have the current version with the same license. It gives you time to prepare. You can also do things like pull packages in from a public upstream into a quarantine and tag them and promote them to your production repositories once cleared. And we'll touch on that in a moment in an example. Now, these are all held in your environment under your control as part of your software bill of materials. It also provides your security teams with a proactive view of how packages get pulled in. So let's look at a practical example of what can happen if your supply chain isn't secure. Now, as I'm sure a lot of you are aware, in February, it was revealed that over 35 major companies, including companies like Apple and Tesla, were found to be vulnerable to the injection of malicious packages into their software supply chain. It's been called the dependency confusion attack or package name squatting attack. And the process was roughly this. An attacker identifies the name or names of private internal packages, primarily through leaked information. They then upload a package with the same name as one of those private packages to one of the public repositories. Again, anyone can upload. There's very little or no checking performed. All they then have to do is wait for a build process or an individual developer to try to pull the package. And what happened was that the malicious package was pulled from the public upstream instead of the private repository. Now, by the time the malicious package has been pulled and an attempt made to install that package, remote code execution has been achieved, thanks to things like package pre-install scripts. And in a CI environment where there may be nobody actively monitoring builds, this failure could go unnoticed for a while, especially if the malicious package allowed the build to be successful. The supply chain has been successfully exploited. So, what does a possible solution to this look like? And how does continuous packaging help? Well, one way to mitigate this attack is simply not to use public upstreams at all and to manually obtain and verify all packages that are used one by one every time. But of course, beyond the smallest of projects, this really isn't feasible, and it certainly doesn't scale up. But another approach, building upon those principles of provenance and isolation, could look like this. So have two private internal repositories, one unsafe with public upstreams enabled, and one that's called vetted or safe with public upstreams disabled. Packages are then pulled from public upstreams into the unsafe repo, where checks of the package signatures and checksums can all be automated and vulnerability scans can run, thus providing the provenance. If all these checks pass, then more automation can promote the packages over to the vetted or safe repository, ready for use by development teams and build or deployment processes. And that's the only repository that they gain access to. They are isolated. So really, rather than just being a consumer of packages, be a curator. Use package promotion and draw a traceable thread from build all the way to deployment. And now another example, just last week, in fact, of what can happen when you don't secure your software supply chain is the recent breach at CodeCov. Now, CodeCov is a tool used by thousands of development teams, and it checks the amount of source code that's covered by tests. That's very useful. it's a widely used tool. Now, what happened was that a leak of some internal credentials allowed malicious actors to update one of the scripts, an uploader script that was provided by CodeCov. The malicious actors, who have yet to be identified, modified this script to grab any environment variables that were present when the script was run, and then export these variables. Now, in a CI environment, these variables will commonly contain things like API keys and access keys, secrets that are required as part of the build process. This breach exposed these secrets to the malicious third party. It went undetected for months, by which time the script had been downloaded and used by many users. The precise numbers is still being determined as organizations react and audit their use of CodeCov. And how was it detected? Well, a CodeCov user that had a cached copy of the script, so that's isolation, was able to compare the checksum of the cached copy with the copy that was publicly available, and that's provenance. They alerted CodeCov, and the breach was discovered. Now, this is not a theoretical situation. This is real world and a real life example of what happens if you don't have provenance in isolation. So basically, when you can guarantee the provenance and isolation of your packages, you can defend against things like dependency confusion. That then, it leaves the next problem. Delivery of these packages from your single source of truth that provides that provenance and isolation. And that brings me to my next point, acceleration. We now live in a remote, distributed world. And even as we emerge back towards what we knew as normal, it's hard to see how we will go back to the old normal. Development and operations are all now work from home jobs, at least part of the time. And it's not just distributed teams anymore. It's distributed individual team members. So we need tools that provide strong collaboration and normalize the behavior no matter where in the world you sit. Now, package management, it's a very chatty interface from package manager software running on local machines, communicating with package repositories on servers elsewhere. So there is both art and science to efficiently minimizing the communication times between where you are and where the data resides. So what you need to do is implement package management on a global scale, providing each team member with an optimal experience. And you need tools that are built upon the native technologies of package managers that speak the native language. Now, some package protocols, like Maven, for example, are extremely chatty. You need full support for all of these, but also with the best possible performance. So you need abilities like accelerated index creation, ideally done dynamically, to provide your packages and containers to the edge at speed with global points of presence. Now at Cloudsmith, we developed what we call the Package Delivery Network, or PDN. It's like a package-specific version of a content delivery network, but it's smarter and it's more context-aware. It knows that it's dealing with software artifacts, and it's built specifically for software distribution at the edge. So no matter where you are deploying packages, using packages, or pulling packages, every team member gets the optimal experience with super fast access times and low latency performance. So I suppose that leaves the question of how do you actually build and implement continuous packaging? Well, there's good news here. You've actually already started. And I say that because package management itself, which you are likely doing in some form already, is the foundation for continuous packaging. Continuous packaging is entirely built upon package management. In fact, it's an extension of package management. It brings package management forward for the fully distributed DevOps age. So you have already started down the path to understanding continuous packaging. You're using native package management tools. You're uploading to and downloading from registries and repositories. But what is really important now are new tools like Cloudsmith for control, visibility, analytics, and accelerated delivery on top of the information that you already have and the foundations that you already have in place. So in summary, and the key points that I want you to take away from this is to successfully secure your team or organization's software supply chain, you need to focus on provenance, providing that chain of trust, and isolation that gives you, the control and the visibility, and acceleration. The package delivery network provides you with the cloud native acceleration to accommodate globally distributed teams and distributed team members. You have heard me say provenance and isolation and acceleration a lot through this talk, and that's the key points. Now, anybody who cares about security needs to know this. Continuous packaging builds a chain of trust for all packages and containers used in your infrastructure, and it empowers you to deliver these packages to where you need them to go. Most people wouldn't entertain multiple tools to manage source code or multiple platforms or tools to manage CI or CD. They settle on a single best-in-class tool. Well, packaging needs to be the same. And you put that together with your CI and CD processes, and you are continuously packaging. Now, hopefully, what you've heard today is enough to ignite a bit of a debate within your own organizations. What are you doing for packaging? Do you have a central single source of truth for software artifacts? Or do you have many disconnected tools? And how does this all fit in with your CI/CD processes? These are the types of questions we would love to talk to you about more. So come and see myself and the team in the Cloudsmith digital booth. We would be happy to talk more about continuous packaging or walk you through some demos. Thank you very much for taking the time today to listen to this masterclass talk. And in the short time we have remaining, I'm happy to take some questions and answers. Okay, we've got a question already. That's great. So Alex asks, why do package managers such as NPM not employ, stricter inspection of uploaded packages for malicious and redundant code? That is a really good question. That's an excellent question, because that's part of the problem. And I do think we will see a shift there. Some of it is down to sheer volume, okay? Millions of packages. And some of it is that it just hasn't been a focus thus far. Now, as supply chain attacks become more of a threat, I do see that changing. And, organizations themselves, they have to take some ownership for this. And that's what provenance and isolation is for. You can't rely on other people to do it for you. You can't rely on public repositories to own that responsibility. You need to, as I said, to draw that thread from build to deployment yourself. And the tools exist for it. The tools exist for you to implement that. So it's definitely a problem. And I do think we'll see some improvement there. But really, the answer is to own it and do it yourself. You don't trust security scanning for source to open. You wouldn't take an open source thing and just trust that it had been scanned at source. You would do it yourself. So you need to apply the same principle to packages, especially ones that you consume from a public upstream. So any other questions? I think we're actually almost out of time. I think I talked for a little bit longer than I was supposed to. But again, if you want to follow this up with a discussion, come and see us at the Cloudsmith digital booth. More than happy to continue this discussion and demo anything about the product that you want to see. Thank you very much again for your time. It was a pleasure today to talk to everyone. I hope you enjoy the rest of Collision, and I hope to see you again soon and to continue talking about continuous packaging and the importance of continuous packaging. Thank you.